Welcome everyone. In this video, we are going to solve some questions regarding NMR. These questions are not just useful for students who are studying A-level chemistry, but it's also important for students who are studying pharmacy and chemistry science. These are the most recent Cambridge past paper questions for 2023 and 2022. I hope you can take advantage of this video, guys. So let's start with the first question. The proton NMR of compound T is shown here. It's dissolved in CdCl3. So here we have this compound and this NMR, H-NMR of it. Yeah. And the first question is, suggest why CdCl3 is used as solvent instead of CHCl3. So we know, guys, any hydrogen in H-NMR and hydrogen NMR, it will give a peak. Okay, so this solvent will give us unknown yeah, it will give us a peak. Okay, we don't want to have this peak in the spectrum, so we just avoid using this solvent. Okay, we prefer using CdCl3. So the answer is because CHCl3 will give unwanted peak, okay? But CdCl3 does not. For the second part of the question, complete table 8.2 for the proton NMR spectrum of T. Okay, so when we have a chemical shift at 1.2, this one, okay, so and here we have alkyl group that is yeah, we have this alkyl group, CH3. Yeah, because look, guys, here we have CH3 and here we have CH2, okay? So because we have a triplet here, a peak of triplet, okay, that means that beside this peak, we have two hydrogens, okay? So here we have two hydrogens. That's why here we have a triplet. And as well as this CH3, the protons here are connected to CH2, which is alkyl group. That's why the chemical shift is low. Okay, it's almost 1.2. We don't have a strong electronegative atom. That's why we have lower chemical shift. Okay, so this alkyl group is connected to another alkyl group. Okay, so we can say here that this is CH3. Okay, CH3. Yeah. And for the environment, we can write RCH3, R for the alkyl, okay, R for this CH2. And the splitting pattern is triplet. Okay, we have a triplet. And the number of protons or hydrogens responsible for this is 3 hydrogens. 3 hydrogen atoms. For 2.8, this peak, okay, it's also triplet. And look, guys, whenever we have the area between 2.2 to almost 2.9, this area belongs to something hydrogens, or the carbon of the hydrogens must be connected to carbonyl group. Okay, well, anything within this area, so we have something connected to carbonyl group, which is here. Okay, this CH2. So this CH2 connected, the carbon of this hydrogens is connected to carbonyl. That's why it gives a peak in 2.8, okay, within this area. And it's also triplet because here we have two hydrogens. This carbon, we have CH2. Okay, the rule is N+1. So we have a triplet. Okay, so you can write it's COCH2. Okay, and yeah, we said It's a triplet, and the number of hydrogens responsible for this two hydrogens. For 3.7, or just let me start with the, 3.7. We have a triplet, okay, we have a triplet. All the remaining peaks are triplet and quartet. Here we have quartet. Type. So look, guys, let me start with 3.9. As you see here, we have quartet. So you might be confusing with the, let me erase everything. 1 second. You might be confusing, okay? You might be confused, sorry, between 3.9 and 3.7, okay? And the remaining hydrogens here and here, which one is which? Okay, so we can understand this from the splitting pattern. As you see here, these two hydrogens, beside them we have CH3. Okay, so their splitting pattern will be quartet, N+1. So here we'll have 4 hydrogens. Okay, so on 3.9, which is a quartet, we can say that here we have OCH2, and splitting pattern, as we said, it's quartet, and the number of hydrogens, still 2 hydrogens. And for 3.7, so it must be the ClCH2. And we have a triplet, and we have 2 hydrogens. Okay. So I hope this is clear for you. For the next question, explain the splitting pattern of the peak at 3.9. So in 3.9, guys, as we said, that we on this on the CH2, beside the CH2 we have CH3, we have 3 hydrogens, so we get quartet. We can say that according to N+1 rule, CH2 gives, or the hydrogens over this carbon give a quartet according to N+1 rule. So 3 + 1 equal to 4. Okay, N is the number of adjacent carbon atoms. Sorry. Yeah, N is the number of adjacent carbon atoms. So we can say that here we have 3 adjacent carbon atoms. So according to N+1 rule, we get 4 peaks. Quartets. Right. Moving to the next question. Just 1 second. So in this question, we have alanine amino acid reacts with methanol. So we get ester, this ester here. So this is the H-NMR spectrum of ester G, dissolvent D2O. Okay, the solvent is very important. When we dissolve something in D2O, the OH peaks and NH2 peaks disappear. Okay, so keep this in your mind. Okay, what's the question? Complete table 7.2 for proton NMR spectrum of G. So we need to complete this table. We have the peak at 1.4, and we need a splitting pattern, number of H's responsible for this, and adjacent carbon atoms. 1.4 here, guys, this peak. So when you see this, look, guys, to make the question easier, just try to show the carbons and hydrogens. For example, here we just write CH3, here we write CH3. So here we have CH. Okay, just try to show all the hydrogens you got. So this one, Okay, we have doublet here. Because we have doublet, that means the hydrogens, or yeah, the group of hydrogens beside them, there is only one H. So that's why we get doublet. Okay, so this is the only thing that will give us a doublet. Okay, here we have CH3, and on the adjacent carbon atom we have one H. That's why this CH3 group will give us a doublet. So splitting pattern is doublet, and the number responsible for this, 3 hydrogens, and the number of protons on the adjacent is 1 hydrogen. For 3.5, as you see here, we have only one peak, okay, singlet, I mean. طيب, okay, so yeah, we have singlet on 3.5, it's one peak, and this one, guys, belong to this group, CH3. Okay, so whenever we have something between 3.3 to almost 4, here we have the carbon of the hydrogen is 99% connected to oxygen. Okay, whenever we have this, so we have connection with the oxygen atom. That's why here we will have 3 H's and the adjacent hydrogen atoms 0. Okay, the last one, this one, on 4 we have we have quartet. So this H, okay, the proton here, its neighbor carbon atom has 3 H's, so it gives us quartet. Okay, so this one is a quartet, and the 1 hydrogen responsible for this and the 3 hydrogens are the adjacents. Okay, so we don't see any other peak of hydrogens of NH2. We don't have any peak belong to this because we use D2O. طيب, let's see the next question. The proton NMR spectrum of G dissolved in CdCl3. Here we use another solvent. So describe the difference observed between this spectrum and the proton NMR spectrum in D2O. Okay, so what will happen if we use CdCl3? What will happen is we're going to see another from 1, almost 1 to 5, a peak on 1 to 5, okay? And this peak will belong to NH2. And the reason is when we use D2O, we don't see this peak. It doesn't appear because there is exchange, okay? Proton exchange takes place. For example, when we have D2O, there is constant changing of the hydrogen and deuterium, the hydrogen of NH2 and deuterium. So what will happen is one of the hydrogens will be replaced by a deuterium atom from D2O, and it becomes NHD, and here we will have HDO, okay? That's why we don't see the signal, okay, or the peak of the hydrogen of NH2 due to the constant exchanging of H atom with D atom, okay? So H hydrogen exchanged with H. So moving to the next question. Yeah. So the proton NMR of this compound, lidocaine, is shown in this figure. Okay, so here we have the compounds, and here we got the NMR spectrum. So then the first question is, name the splitting pattern at 2.6 and 1.1. So at 1.1, here we have a triplet. And on 2.6, where is 2.6? Yeah, here we have a quartet. Quartet. طيب. This is the first part of the question. Moving to the next part, the relative peak area of the peaks at 3 and 3.2 is 1 to 3, respectively. Okay, so you need to read this statement 2 or 3 times to understand it. The relative peak area, which tells us how many hydrogens atom we have in a specific location. Yeah, the relative peaks area at peaks 3 and 3.2 is 1 to 3. So what it does mean? It means that on peak 3, if we have 1 H, that means on 2.3 we have 3 hydrogens, okay? This is the meaning. If we have here 2 hydrogens, here we have 6 H's. If we have here 3 H's, here we got 9 H's, okay? Triple it, just triple it. This is the meaning of this. Okay, so you need to keep this in your mind. Let's just erase everything. Yeah. Identify the protons in H-NMR spectrum of this compound that are responsible for the peaks at the following chemical shift. So here we have at 7.1, yeah. So yeah, at 7.1 here, so this area always belong to protons of benzene ring. It always gives at 6.5 to 7, and we usually have multiplet for this. Okay, so here we have protons of benzene ring. Okay, this is the protons of benzene ring. So guys, the trick here is we have two peaks, 2.3 and 3. Both of them are singlets, and we need to know the hydrogens, the protons responsible for these peaks. So look, guys, when you try to solve this equation, just as I told you, make the question simpler by writing trying to write the, for example, not skeletal formula, actually, the structural formula. Okay, just try to make the formula or display formula, just to make it simpler. So for example, here, instead of writing this way, just write N. Here we have CH2, CH3, and here we have another CH2, CH3. Okay, so if you suspect these protons for giving 2.3 or 3, so you can say, so you can neglect this idea. Okay, this is totally wrong, because both of them, this one will give us quartet and this one will give triplet. Okay, and both peaks here are singlets, so we can ignore this part. Here we have CH2, and this CH2, yeah, it gives a singlet, right? Another protons that will give a singlet is here, this CH3 and the CH3 that is here, okay? These CH3s both are identical. They both in the same chemical environment. So knowing the hydrogens that are in the same chemical environment is crucial for solving such questions. Why these are in the same chemical environment? Because as you see, these CH3s, both of them, just 1 second. Yeah, 1 second. Yeah, both of them, they have the same connection. For example, both of them connected to carbon that is connected to carbon, yeah, to this carbon that is connected to N, okay? Both of them, they have the same space from it. Both of them connected to carbon that is connected to carbon, another carbon here. So both of them are in the same chemical environment, and both of them will give singlet because they don't have a neighbor carbon with H. So both of them are giving singlet. Okay. So now we know that CH2 and these CH3s will give a singlet, but which one is a 3 and which one is 2.3? Look, guys, now let's go back to this. Because, guys, carbonyl, this CH2 is connected to carbonyl, so it will give from 3 to 2. It will give in this area, okay? Both of them, they will give in the same area. But which one is which? We can identify it from this, okay? The relative peak area of the peaks at 3 and 2.3 is 1 to 3 respectively. So as I told you in the beginning, when we have one H here, that means we have 3 H's here. When we have 2 H's here, so we have 6 H's here. I hope, guys, now it's clear for you. So we say that at H we have, at 3, sorry, we have CH2 that is connected to CO, and on, on 2.3, we have a real AR that is connected to CH3, okay? These are the hydrogens responsible for this, okay? طيب, the last part of the question, predict the number of peaks in carbon-13 NMR for this compound. طيب. So just let me erase everything now and start solving the question. Yeah. طيب. So look, guys, now we try to count how many carbons atom do we have. So as you see here, as I said, here we have N, CH2, CH3, and CH2, CH3. So here we have only we count 2 carbons because look, guys, here we have 4 carbons. Yeah, that's right. But look, this CH2 and this CH2, they are both in the same chemical environment, so both of them will give a peak in the same area. Both of them connected to N, both of them connected to CH3. So this one will give 1 peak, and this CH3 as well will give 1 peak. So here we have 2 peaks. This one will give a peak 3, and this one will give a peak 4. So here we have 4 peaks, 5 peaks, and look, guys, this carbon, let me draw them with another color, just 1 second. Yeah, that's blue. This carbon atom and this carbon atom will give peak in the same area. They are in the same chemical environments. Why? Both of them have CH3. Both of them connected to C that is connected to N. So both of them are the same chemical environment. Okay, so both of them will give 1 peak. These 2 carbons as well as will give 1 peak, and this carbon also will give 1 peak. So here we will have 4 peaks, and these 2 CH3s, both of them also will give 1 peak. So 4 plus 1. And as we said, here in total we have 4. So we have 9 peaks. Okay.